Hi everyone, this is the gas walkthrough for January 31st. I'm Philip Newman. Today I'm solving Count Different Multiple Arrows by Bill Murphy. We've done some Count Different puzzles before. Bill has said a few of these, I think. I think Clover's done one too. I don't know if I have, but this is a little twist on that. We have normal Sudoku rules, 1 to 9 in each row, column, and 3 by 3 box. Additionally, we have some arrows in the grid. And the circle digit tells us how many different digits are found on the arrows connected to it. So, whereas normally with count different arrows, you would just consider one arrow, and there would only be one arrow coming out of it. Here we're considering all of the cells on arrows coming from this circle, this bulb. So this clue is telling us there are 3 distinct digits in these 6 cells. This 2 is telling us that there are 2 distinct digits in these cells. And those are the rules. So, the first thing we can look at here is these 3 have to be different, and these 3 have to be different. So if we only have 3 different digits total, then whatever these 3 are must be the same as these 3. So we know there's a 1 here somewhere. We know there's a 6 here somewhere, and it can't go there. Additionally, we know there's a 1 here somewhere because these are 3 digits that have to be different that are on these arrows. So this has to be the 1. And now these will be our last digit. I'm just going to color them green for now. We can narrow them down a little bit. Can't be 5. So these are from 4, 7, 9. Alright, let's look at this one. Same deal. 5 has to be on this arrow. 4 has to be on this arrow. There's only one way to do each of those because of this 5 right here. And then these are going to be the same. Let's go purple for that. And they're from 8, 9. We see all of the other digits like that. Alright, down here, we need 8 on this bottom arrow. Can't go here, so that's an 8, and that's going to make these 9. 4 can't go here, so it must go here. And then these are going to be the same. I'm going to make these purple now, since we've figured out our purple up there. The options here are 6, 7, 9, I believe. 1, 2, 3, 4, 5, 8. Like that. And then this one. 9 needs to go down here, 7 needs to go here, so the 9 is there. 7 could go in either of these cells right now. But let's think about what this digit can be. It can't be 2, 3, 4, 5, 6, 7, 8, 9. It must be a 1. So now we know this is a 1, 7 pair. There's a 1 here, if I can click on it. So 1, 7 go like that. Alright, let's look at the 2 clue now. So we only have 2 different digits in these 6 cells. And there are an awful lot of pairs going on. So for example, these have to be different. So let's just call this our blue digit and this our orange digit. This can't be orange, so it must be blue. This can't be blue. This can't be orange. And this can't be blue. So these digits are going to be the same, and the blue digits are going to be the same. So what can the orange digit be? Well, it can't be 1, 2, 3, 4, 5. So does it see a 6? It does right there. 7 or 9. So orange must be 8. Actually, I'm noticing the 9 down here eliminates 9 from green. The blue digit. It can't be 1, 2, 3, 4, 5. Could be 6, unless I'm missing anything. In fact, it's going to have to be 6. It can't be 7, 8, or 9. I noticed it had to be 6 a completely different way. I started looking at this column, and we need 2, 6, 8 in these cells, and there's a 2 and an 8 there, so that had to be 6. In fact, this has to be 2, 8 like that, with a 7. And we can fill in our 6s here. That means purple is not 6. So let's get rid of this coloring. And we still haven't resolved this or this. I think that's right. Alright, we need 3, 4 in these cells. Let's look across here. We need an 8 in the row. There's an 8 there, there's an 8 there, so this is the only place for 8, and now this is 7 and 1 because of that 1, and that's going to give us our green digit. Let's get rid of that coloring. Alright, this row, 2 and 4 can't go in this cell, so this must be 6. And this is a 2-4 pair, but we have a 4 there. These are 5 and 9. I will go ahead and fill those in. Let's look at this column. These are 1, 3, and 7, and this is not 3. That wasn't that helpful. What about this one? 5, 7, 9. This is not 9, this is not 5, and this is not 9, but not 9. So this must be our 9. And now we have a 5, 7 pair here, so this is 1, 3, 7, like that. 6 and 8 we can do from the 8 there. Alright, these are 2, 5, and 6. We've got a 5 there. That's going to resolve this. And we've got a 2 there. It's going to leave 1 here, and a 7, 9 pair, of course. But we can resolve the 7 9s from this 9. So purple has to be 7, and this has to be 9. And we're done with our coloring. Alright, these have to be 2, 3, 4, 5, and there's 2, 4, and 5 in these cells, so this has to be 3. And the 5, 9 looking down, or the 5 here, resolves the 2, 5. 1 and 3 in the box has to be in this order. This is 4. These are 2 and 9, which is resolved. Pretty much everything should be resolved at this point. We don't have that many cells left. 6, 9 here is going to resolve our 9 and 5. The 5 now has to go here with a 2. And our last digits are 7 and 3. And that's the solution. Really nice puzzle by Bill. I like, there's symmetry in this, obviously, with how the clues work. I like that, for example, this one resolved very differently from this one. Figuring out the 1 here, things like that. I like when we have demonstration of kind of the basics of a variant, but with a variety in the deductions. I know I tend to do a lot of symmetric puzzles, and so does Bill, and Clover does this occasionally. We like setting them. They're pretty to look at. But having something that's pretty to look at and symmetric looking, while having some variety in the deductions is really nice. I try to be more aware of that recently. But anyway, I hope you enjoyed that as well. Let us know how you did in the comments, and I will see you next time.